Hey everyone, this is Trashify, the app that allows you to find your nearest trash bin. Alright, so over here we can see that we've been locked into a backend service, alright, which is being rendered on the Next.js server, alright, which just is based off of Node.js. And so the post is also being rendered on that as well. So like if I decide to, add something, I can do it that way. The manage is also being done that way as well, but it's only rendering the specific data that my email account is associated to, and that email account is coming from our authentication service, which I'm using Auth0 for. All right, not NextAuth. But we're using the Auth0, which is basically a fully managed solution for authentication. Reason for this was that I wanted to just quickly get authentication done, so I just abstracted all of that to a third-party service. But for production apps, this is not really a production app. I wouldn't recommend that. So if I were to take this to production, I would probably let it stay with Auth0, but as we scale, I'd probably change it. But yeah, anyways, for now it's fine because this is just a pet project. So all we need to do is just continue with Google, or there's also a username and email, which I actually need to delete because username and email is not secure at all. But anyways, after that, you get your trash bins in your city. Okay, so this is in your specific city. All right, and you can also go to post, manage, all of that. Okay, now the cool thing that I've integrated into this whole app is caching. Okay, and you'll see the whole use case for caching in a second, but how did I implement this caching? Well, that is through a caching software called MEMCACHED. Okay, now this service is very, very popular. A lot of websites use it. Namely, it's being supported by Netflix, right? So they're using it. Facebook is also using it. In fact, Mark Zuckerberg actually implemented it himself, right, to optimize API calls. So yeah, it's very, very popular, very, very simple to use, and very, very high in performance. Hence why a lot of developers use it. So now you might be asking yourself, what is caching? Now I made a very, very good article on it. So if you just go to hemiddev.wordpress.com, I'm going to be adding like a search component later on, so you can just search for it, but it's just basics of caching. Alright, so you can go ahead and read this and you'll get a very, very good good in-depth example of what caching is. But in terms of just explaining it very, very quickly for context, caching is just temporary data which is very, very fast to retrieve. So you can use this for very highly available data, which doesn't change that often, right? So if it doesn't change that often and it's very, very highly available, it allows you to basically save on API calls, right? Because API calls do cost money, from the server to the database, all of that, right? So by using this cache, it's much more faster, first of all, and much more cheaper as well, and overall a better user experience and developer / company experience as well. Okay, so now that you know that, how is Memcache, or I should say any caching system, that fast? Well, first of all, it's an in-memory database. Alright, which means that the data isn't being stored on a hard disk or an SSD like a traditional database would, but it's actually being stored on the drive itself. Alright, on the memory, I should say, sorry, itself. This means that you don't need that extra transaction to actually access the hard drives of the SSD, and you can just quickly get it from the server itself. Alright, it's also key value pair as well, which really helps. And yeah, now another quick thing to note is that with caching, the data that you give it has to be small and very, very simple. Alright, for my use case, you'll see that as well. Okay, so let's get right into it before confusing you even further with a system designs. So this is how my service sort of looks like right now. I'll explain everything. It might look a little intimidating, but it's very, very simple. Essentially, this is our front end. Okay, This is our backend API, and then this is our backend services, which includes our caching system from MEMCACHED, MEMCACHED, sorry, I keep saying CAD, MEMCACHED, and our database. In my case, I'm using MongoDB, and Prisma is my ORM. So essentially what's going to happen is the API is going to get a request from the front end. All right, so so the API gets a request. Okay, so then what the API is going to do is, let's say we asked to get all the bins in our specific city. Okay, so how does the API know what city we're in? All right, what city are we located in? Well, to actually get that city, there's multiple ways we can do it, but mainly you're gonna have to use an API. All right, so the API is actually going to be making a request to another API. So you can see how this can add a lot of performance issues. But don't worry, this API is really fast, so it doesn't add too much, performance problems. But you can see that it still adds a lot of it will still add a lot of response time to our API response, because we are calling on a API, right? But anyways, it calls on this API to get the city. Okay, then it gets that city back. All right, this API gets that city back from this external API. So this API now has the city of the user through the IP address. Okay, then what it will do is it will go ahead and cache it. Okay, but actually before this, I want to explain this without the caching system. So pretend Memcache and this whole caching thing that I talked about does not exist. Okay, so this is the solution without caching. Okay, so anyways, we get that city back, and then based on the city, we're gonna query into our database, and then the database is gonna give us all the posts back with that specific city, and we send that right back to our front end. Now imagine doing this repeatedly over and over and over and over again. Imagine first of all how much that API would cost, first of all, right? Because that API is not free. Okay, that API costs money. Okay, there's API keys to it. So imagine that a user just keeps spamming this API with like request, right? Imagine how much API request our API is gonna request to our external API, right, to get that city, right? Because this API is getting our city. It's gonna become a very costly in a very short amount of time. So instead of doing this, how about we store it in a temporary store, which we can delete after like an hour or so. I have an hour, right? So then we're not having like fully updated information in terms of the user's whereabouts, but it's only an hour, right? So it's not that big of a deal. Okay, so anyways, instead now let's bring our caching system into the picture again. So now what's gonna happen is I'm gonna request to the API, and the first time the API is gonna do exactly what I told you. Okay, it's gonna go to this external API, it's gonna get the response from that API, it's gonna use that city that it got from the response to actually query to the database, and then get a response back, send it. Okay, that's fine if you only do it once, okay, because this API is meant to be used, right? But now this is where it's different. When this API first goes, right, like first is being requested, it will, before you even request to this API, what's gonna happen is it's actually gonna go to this MEMCACHED server. Okay, so it's gonna go to this MEMCACHED server, all right, and it's gonna see if, based on your user email, is there a city. All right, so remember how Memcache is storing key value pair. The key is going to be your user email, and then the value is going to be the city you're in. So it's going to just check if there's a key belonging to your specific email. If there is, instead of going to that API, it's just going to simply retrieve that city from there. All right, so you can see that way we're saving that API request. All right, now let's say that you did not have a city, all right, or you do not have a key with your email, then what it will do is then it will make that request call, and it will add that city that it got from that request call to that cache. Okay, so that way we're always going to have a very, very updated city. Okay, it's not going to be fully updated because again there's that 1 hour delay period, but still it's much more cheaper and much more faster, I should say, that's the most important part, than just keep requesting this API. All right, so that's why I decided to implement this caching system through MEMCACHED. Now there are other ways that I could have done this. I could have used like Redis, and there's also solutions that you can just add within the API itself, right? So that your API also acts like a cache, and you're going to be using the memory of your API itself. But then you're going to be restricting the performance of the servers that are running your API, which will kind of ruin the point of having this caching. And with Redis, I mean, Redis is also a good option, but I just want to try out MEMCACHED, and it's much more simpler to get started than Redis, in my opinion. But anyways, now that you know this, let's actually see the code. All right, so I'm just gonna show you guys in GitHub. So if I go to Trashify, all right, this is all open source, by the way. I'm just gonna go into my pull request. So this is the branch that I'm working on. If I go into my commits real quick, here's where I added it. API performance added right here. So you can see that I'm very good at documenting my commits. All right, and you can see this is not that really good to see, so I'm just gonna go into the code. Let's go to app, and let me just open up utils here. So over here, this is where I added my logic for the MEMCACHED, and you can see that there's just a helper function which allows you to implement exactly what I was just talking about, right? So actually, you're gonna see me commit some stuff to GitHub, because I actually changed the way that I identify my keys. Before I was using the app session, but then I realized that there's no performance issues with just using the email from Auth0, so I'm just using that. Because this is much more reliable than using whatever I had before, especially because I had to create a whole hash, which also added operational overhead. So I'm just using this now, and so I'm just gonna say changed uniqueness from app session to email. And yeah, that's pretty good. I'm just gonna get the correct wording. Let's commit this, sync changes. Okay, perfect. So let me go back to GitHub now. I think we should be updated now. Cool. Okay, so now if I look over here, you can see that this is where we're getting our email, and that's all abstracted by Auth0, right? Now over here in this try catch block, we're actually going to be checking the cache. Okay, so this is where we're here. So this is where we're in the API, by the way. We're calling this function in the API, and what's happening is essentially this API is first requesting to the MEMCACHE server. Okay, it's requesting the specific key that we have set up, and we have it set up in this format. All right, and if you look here, this is how we do that, right? We just do memcache.get. It's as simple as that, right? So anyways, we make that request from the API. Then MEMCACHE is gonna look in its in its memory and it's gonna see if you have that specific key within your within the server. Now, if you see here, this is where we're seeing if the cache data is returned, right? So we're over here, we're giving a promise, all right? And if this promise is fulfilled, basically we're saying that return cache data. So then we're just gonna be giving the cache data back to the API, which the API can go ahead and transfer to the server. But if this doesn't work, right, if this if statement is not valid, right, it doesn't work, then this block of code is going to run, in which we're actually going to be fetching to the APIs. All right, so we have two APIs here actually. First is to get your IP, and then the second is the geo response, which will get your city. Okay, and then since we did this, all right, what we're going to be doing then, all right, because we sent back a response of not found. Okay, so the API is going to go, okay, then well, not the API, this helper function, but it's part of the API logic. But anyways, then the API is just going to simply request to the external API. Okay, that's what's happening here. It's requesting to that external API, and then that external API is adding it, or adding the response it gets to the MEMCACHED server, which we can see here, right? It's setting the city, and the city is this, and we're getting that from that Axios response, right? And then we're just resolving it if there is no issues, right? Because again, this is a promise, so well, this is right. So if there is no issues, we can just resolve it, which means that the promise was fulfilled and there's no issues, right? This function did what it needed to do. And then if there are no issues or anything, we return the city. So we're always going to have a city. It just depends on how, right? Like over here, you can see we're just returning the cache data, which is the city, right? Because the value of the key value pair is always going to be the data. And then over here though, this is in the alternate reality where there's no cache data, so we need to add it, right? And in that, we're gonna have this bit of operational overhead. That's completely fine if it's not happening too much times, especially because the API that I picked is purposefully really fast, right? It's like 10 milliseconds or something like that, so it's not too bad, right? Like at worst, I see like maybe 300 milliseconds of response time, but with this solution, I got like 50, right? I got 50 milliseconds, which is crazy fast, right? So yeah, that's the reason why I decided to implement this. And so yeah, that's basically just me yapping about caching, and I actually showed you that through this utility helper function I built. And if you guys are still wondering how I added it, if I go into my API, if I go to post, and if I go into my route, alright, everything's fine because everything is in a process.env. But if you see here, actually up here, I'm actually calling it like this, right? So this is how I'm implementing the logic, because I'm just abstracting this logic into a lib folder, and that's because I'm using it 2 times. I'm using the same logic 2 times, so it makes sense to just modulize the logic. All right, and you can see that the whole thing that I talked about in this case is the get command, right? It's the get command, because you can see that after once I run this logic and I get the city, I'm using that in my Prisma, because I'm using Prisma to get my data within my database through the where command, right? So yeah, that is how essentially all my logic works. I also have AWS S3 for my images, so these are not statically rendered. These are from the cloud, right? So yeah, that's another cool thing that I have. But yeah, that is it from me for right now. Very cool use case. This is an actual production level example, and you saw everything in my open source repository, right? It's very simple to get a hold of this code. You just go to literally github.com/hemit99123 and then Trashify like that, and you'll get into my data, my code. All right, so now the next attack plan is to add my RPC microservices. So instead of using this REST framework, which I'm using over here for my microservices, right? Because this is essentially a microservice within my app structure, right? This external API, because I'm using it for a specific service, in my case to get the city. but you can see that it's a REST API, right? So I saw actually that the response time and the whole adding this logic into your API, it adds a lot of response time. So instead of doing this for my AI microservice, which I actually recorded like a month ago, right? I talked about it. Instead of using like a REST API, I'm going to be using RPC, which is much more faster because it acts like functions actually. So it's like essentially you're going to be calling a function, right? And this function just is being returned back to you and executed on the specific server, all right, which is going to be an Python AI server. Okay, so we're going to see all of that, and the code is going to be posted. I'm going to call the AI microservice just Trashify -AI micro micro, right? And yeah, so I'm really excited to talk about all that and show you guys that later on, all right, once I implement it. All right, so that is it from me. I hope you guys enjoyed this video. It's very in-depth. Really, I talked a lot about system designs, MEMCACHED, and that's kind of just what I've been working on with Talum and my lead coding journey. So take care.